Afternoon, ladies and gentlemen. Good morning in the Americas and good evening in Asia. Welcome to the free webinar, Ultra-Low Emission Epoxy Systems Offering Long-Term Metal Protection, presented and sponsored by Evonik. My name is Kirsten Breda. I'm editor at the European Coatings Journal, and it'll be my pleasure to guide you through this online event today. In this webcast, Dr. Suhal Tunçay, Manager Applied Technology for Coatings at Evonik Resource Efficiency in Germany, will discuss long-term metal protection with the aid of ultra-low emission epoxy systems and introduce solutions to comply with emerging VOC regulations. Welcome, Suhal. How are you today? I hope everything's fine with you. Just a quick hint for the discussion later. On your screen, you can find a question tab on the control panel for your questions to our speaker. Please type your questions or comments here at any time during the presentation. I will collect the questions so we can discuss them with our speaker after the presentation, and we can offer you a direct answer to your problem or to your questions. Some words about our speaker now. Dr. Suhal Tunçay studied chemistry and polymer chemistry at the German universities of Bochum and Dortmund, and obtained her PhD in chemistry at the University of Paderborn in Germany in cooperation with Evonik Crevis. In 2016, she started her professional career at Evonik Resource Efficiency in Marl, Germany, where she's currently technical manager, applied technology for coatings in the department, crosslinkers, epoxy curing agents in the EMEA region. Hello as well. Are you ready for your presentation? I hope you can hear me. Do we have a little problem maybe with the microphone or the webcam?
Can you hear me now?
Yes, I can hear you now very well.
Okay, perfect.
Welcome again, and I hope you're ready for your presentation.
Thank you, Kirsten. Actually, I'm ready. We can start. And first of all, thank you very much for the nice introduction.
You're welcome.
Yes. Hello, everyone, and welcome to today's webinar. Today, we are going to talk about how you can achieve ultra-low emission levels with your epoxy coating, and at the same time get high durable coatings with the 3 new products from Evonik. Products at glance today are Ancamine 2712M and Ancamine 2739 and Ancamine 2769. Those are amine curing agents for 2-component ambient cure epoxy coating, which can be used in any application where long-term metal protection is essential, such as in marine, protective, and industrial coating. Next slide. Okay, so within the scope of this presentation, we will review general market trends and drivers within the coating industry and how those impact the innovation and development for epoxy coatings over years. Based on this, we will discuss here the technical challenges the epoxy coating industry has been faced with. Then we will take 3 new products under the loop and discuss how those new products support your formulation to meet environment regulation targets. The key features such as performance attributes will be discussed here. At the end of the presentation, I will highlight the benefits offered by those new products. Okay, then let's take a look on the market trends and drivers. Requirements within the coating industry can be divided into 3 major drivers. Coating suppliers are being asked to provide eco-friendly solutions which enable their customers to enhance the performance and improve the productivity. Regarding the needs of environment, the coating industry asks for products with low or zero emission with improved EHS profile, where the use of harmful raw materials is avoided. If we move to the performance requirements, to protect the metal longer term, it is required to provide products with improved corrosion resistance and barrier properties respectively, enhanced durability over time, which means that the properties of the coating don't change over service life, improve adhesion also to poorly prepared, even rusted surfaces. Last but not least, for the enhanced productivity, has been asked to have paints which can significantly lower the cure time and exhibit robustness against adverse condition while curing. That will reduce downtime and create a wider application window. We do see our role as a curing agent supplier as Evonik to provide our customers with the best technology solution to meet all those emerging needs. Okay, allow me to show you how the market trends have impacted the epoxy coating development over years. Since the 70s, waterborne epoxy coatings have a successful track record. Here, typically, polyamides, along with solid epoxy resin, have been used for heavy-duty metal protection. The long-chain fatty acid backbone of polyamides provides a good combination of corrosion resistance, flexibility, and adhesion. However, polyamide curing agents are often high in viscosity and provide limited solvent and chemical resistance. Another limitation of this technology is poor low-temperature cure performance. Typically, polyamides remain sticky when cured at lower temperature. But polyamides provide also excellent pot life, allowing spray application for up to 6 hours when used with solvent-based solid epoxy resin. This normally results in coating formulation with a VOC content greater than 450 grams per liter. VOC stands here for volatile organic compounds. You can find different definitions for VOC between different regions and directives. Therefore, it is important to understand where the coating will be used when referring to VOC levels. For instance, according to European Paint Directive, VOC is an organic compound having an initial point lower than or equal to 250 degrees at the atmospheric pressure. And we do refer that definition in today's presentation when we use the term VOC. So what happened then is at the beginning of 2000, the maximum VOC limits in coating application has been introduced. Then the development work has moved away from traditional solvent-borne coatings to high solids with the target to reduce emission levels. When formulating at high solids, the most significant change is the replacement of high molecular weight polymers by low molecular weight alternatives, which naturally have lower viscosity. Typically, for high solid coating, mannix bases or cycloaliphatic are used as a curing agent along with liquid epoxy resin, which enables the formulator to achieve VOC content lower than 250 grams per liter. The use of different chemistries for formulating high solid epoxy coatings has to lead several performance benefits. Many cycloaliphatic systems can deliver improved low temperature cure since those curing agents react faster and have better compatibility with liquid epoxy resin versus polyamides. The use of lower molecular weight curing agent and liquid epoxy resin results in a higher cross-link density of the cured film. This can improve chemical and corrosion resistance. But we have to keep in mind that the handling and the performance characteristic of high solids are different than solvent-borne epoxy coatings. there is a negative impact on the pot life coupled with an extension of dry time versus solvent-borne system. In case high solid, the polymeric network has to react and build sufficient molecular weight to reach the gel point, or in other words, dry to touch state, where the solvent-borne system are already high molecular weight polymers and dry to touch or lacquer dry as soon as the solvents evaporate from the coating film. To ensure that the high solid system can react fully, the curing agents and the epoxy resin are typically formulated with additional plasticizers such as benzyl alcohol. Those modifiers are also essential components to improve system compatibility, dry speed, and adhesion. One drawback is that under certain conditions, those plasticizers have the potential to leach out during the service life of the coating. This can affect the mechanical properties of the coating and can lead to reduced flexibility. Consequently, the potential to lose the performance is increased over time. Furthermore, due to recent changes in VOC definitions, benzyl alcohol is considered as a VOC, which means it can be difficult to achieve here the ultra-low VOC targets. On the other hand, higher cross-linking density can also lead to reduced flexibility. So, next step. In 2015, another regulatory changes have been communicated, where the maximum VOC level of the paint targets less than 100 grams per liter. As you can imagine, that was a huge challenge for epoxy coating industry. Beyond meeting the market needs for ultra-low or zero-emission coating, coating suppliers were being asked to provide solutions which overcome the technical challenges of high solid systems, which means robust performance during the service life and good balance of pot life, dry time, viscosity, and flexibility. To address those needs, Evonik developed new amine technology which allowed to design both polyamide and cycloaliphatic type curing agents. In this respect, Ancamine 2712M and Ancamine 2739 has been developed to deliver properties and performance that are typically attributed to hardeners based on cycloaliphatic amines, where Ancamine 2769 has been designed as a polyamide curing agent. So, while meeting environmental regulation targets, new curing agents provide many performance benefits. Those are, we will have high compatibility with range of epoxy resin, low viscosity while containing no solvent or no or very low level of plasticizer, high durability over time, excellent real true cure at ambient and at lower temperature, and high corrosion resistance. Like mentioned before, Ancamine 2739 and Ancamine 2712M have been developed to provide properties and performance comparable to cycloaliphatic amines. Now we are going to review their performance. Here we will focus on handling properties of Ancamine 2712M and 2739. Both products exhibit very low viscosity, with Ancamine 2739 containing ultra-low level of plasticizer and Ancamine 2712M is free of any liquid plasticizer. While Ancamine 2739 has been designed to allow for a longer working life, pot life, 1.5 hours, Ancamine 2712M has been developed to provide coating system with improved blush and carbamation resistant at lower application temperatures. The base handling and performance properties, including gel time, cure speed, hardness development of clear coats, are highlighted in this table. So both products have been formulated to provide a 50 pHr loading with a standard liquid epoxy resin. The unique advantage of the two products is the low mix application viscosity, which is achieved at lower than 10 grams per liter VOC, whereas the standard cycloaliphatic has a VOC content of 160 grams per liter due to the presence of benzyl alcohol. Additionally, the new curing agents exhibit fast drying. The barrier properties of the clear coats have been investigated here as well by using electrochemical impedance spectroscopy, where in all cases pore resistance was above 10 to 8 ohms, which indicates excellent corrosion resistance. Ancamine 2739 and Ancamine 2712M deliver high degree of true cure at ambient and low temperature. To ensure a true cure without vitrification of the cross-linking reaction, the degree of curing over time investigated here by DSC. The data has been obtained after allowing the clear coats to cure for 8 hours, 24 hours, and 7 days. Figure on the left-hand side illustrates the degree of cure. The results show here that Ancamine 2712M and 2739 exhibit rapid conversion with epoxy resin to almost full cure at ambient conditions within 7 days, without the need for high level of plasticizer. Where in absence of plasticizer, the reaction with cycloaliphatics would stop after 24 hours, and full curing cannot be achieved. This demonstrates clearly that the cycloaliphatics need such a high level of plasticizer for a true cure at ambient to build their properties. On the right side, we do see the property development at 10 degrees, in this case, Persos hardness. After 7 days, Ancamine 2712M reached the highest Persos hardness, which it would reach at ambient as well. With modified cyclos, the possible highest range of Persos hardness couldn't be achieved after 14 days. And also here, these results demonstrate clearly the rapid development of the network for 2712M at early stages of curing at 10 degrees. So, formulation based on Ancamine 2739, which has very low level of plasticizer, shows very low level of emission. And there are different ways to measure the emission. Within the European Union, you will find different directives for VOC control. One of the national regulation is from Germany called AgBB, which set quality standards for emission levels. Based on the concept of lowest concentration of interest, the AgBB committee has set the interpretation scheme. And this validates the accumulated emission at 3, 7, and 28 days after applying a coating in indoor applications. To establish the emission levels of formulation based on 2739, panels was submitted for emission testing following AgBB protocol. The first measurement was performed after 3 days, cured at room at ambient. So the figure on the left side show less than 1% emission of VOC components of the maximum norm and no detection of SVOC on carcinogenic substances. As a result of this extremely low level emission, a second measurement was performed after 28 days. Here, no VOC, no SVOC or cancerogenic substances could be detected after 28 days. Those results clearly demonstrate that the coatings based on Ancamine 2739 curing agent would pass the AgBB test. And in this case, it can be categorized as an ultra-low emission coating systems. Ancamine 2739 and 2712M provide consistent performance after thermal aging. To explore the durability of cure coating after thermal aging, 2 additional sets of panels of clear coat were prepared. The first set was allowed to cure for 7 days at ambient temperature, and the second set of coating cured for an additional 2 hours at 150 degrees. The glass transition temperature, the crosshatch addition, and direct impact resistance were measured here. In all cases, the TG of first set was around about 55 degrees, whereas the second set exhibited significant increase in TG in case of cycloaliphatic amines. So you can see cycloaliphatic amines has, after the post-cure, a TG of 110 degrees. Also, the crosshatch addition and direct impact test of cycloaliphatic amine was negatively impacted by the additional heating in the second set. So here, the crosshatch test is rated for the first set with a 5 as a rating, where the second set got a 3 as a rating. Suggesting here plasticizer migrates out from the coating during service life with the consequent danger of stress accumulation and loss of adhesion. Same for direct impact. We observed dramatic decrease for cycloaliphatics here as well. In comparison, 2712M and 2739 based coatings show no performance changes after post-cure. Panel used for cross-hatch test after post-cure, you can see on the picture right side as an example. Anticorrosive primers based on Ancamine 2739 and 2712M provide a good balance of cure performance and excellent corrosion protection. We compared performance of anticorrosive primer based on this curing agent against high salt system. Details on use model formulation here you can find on our cross-painting technical data sheets. Ancamine 2739 and 2712M provide fast dry as measured by the dump twist method, corresponding to 9 hours for Ancamine 2739 and 8 hours for Ancamine 2712M, which is comparable to the modified cycloaliphatic amines. Even without high level of plasticizer, coatings based on this curing agent exhibit improved pore-source hardness development versus reference. All coatings provide excellent salt spray and Cleveland humidity resistance. The cohesive failure by pull-off test on this picture indicates to a good adhesion. So now we are going to talk about the third product, Ancamine 2769. Ancamine 2769 is a polyamide with extremely low viscosity, and it contains no plasticizer and no solvents. We demonstrated here the handling properties and how this translates into the providing coating system in clear coat with ultra low viscosity at 100% solids. As you can see, the viscosity of 2769 is 150 millipascal second, and it offers improved resin compatibility without the need of further modification, which is reflected here by the high gloss in cure coatings. Due to good compatibility of 2769 with liquid epoxy resin, no induction time is needed to achieve good surface appearance, and good surface wetting can be here ensured. Even at lower temperature, tech-free, blush-free surfaces can be obtained. Conventional low viscosity polyamide exhibit poor compatibility with liquid epoxy resin and require an induction time before application. These products are usually slow to dry and give rise to tag and poor quality films, often unsuitable for applications at lower temperatures. Pictures on the left-hand side show wetting and film building of clear coat based on 2769 and commercial polyamides. On the right-hand side, we do see the mixture of liquid epoxy resin and Ancamine 2769, which provide a mixed viscosity lower than 1000 millipascal second and give a clear solution and which indicates a good compatibility. Versus conventional polyamide mixed with liquid epoxy resin gives a hazard solution, and the mixed viscosity is too high and require a higher solvent content to be manageable. To demonstrate the effectiveness of the new polyamide, the curing agent was formulated into an anti-corrosive primer. The formulation with a VOC of 85 grams per liter and 2 hours pot life is here prepared. The details here to the formulation again you can find in our TDS, where it's listed what kind of pigments we use and which solvent, which level for this application. The primer can be spray applied with conventional spray equipment immediately after the mixing for 2769. So here anti-corrosive primer formulation based on 2769 exhibit excellent corrosion resistance with minimal or no failures up to 200 hours in salt spray and corrosion test. As you can see on the table, the results for Ancamine 2769 are in line with competitive system, where we can achieve highest rating for creep and field blistering. Anti-corrosive formulation based on Ancamine 2769 show also very good adhesion on poorly prepared rusted substrates, where the pull-off test here we performed indicates 6 megapascal Pascal strength. So let me summarize the results. The ambition to develop new curing agent here was to create sustainable solution across all coating areas, but especially in marine and protective application where environmental regulations can be most demanding. New innovative curing agent technology allow to reduce or even eliminate VOC in paint formulation, which minimize workers' exposure to hazardous chemicals during application. Beyond very low viscosity with containing little or no plasticizer, the new curing agent show high compatibility with liquid epoxy resin, allowing a good surface appearance after curing. So, during the presentation, it has been also shown that due to the absence of non-reactive plasticizer, the coating is more thermally stable and will retain high performance during service life. This will extend the service life of structure and equipment, which additionally reduce their overall impact on environment. High degree of curing through cure at ambient and low temperature with the new curing agent can be also achieved. And at the end, a good balance of properties, including low viscosity, long pot life, fast dry time, and high flexibility, makes the new curing agent technology a suitable replacement for existing high salt epoxy systems. So now we are coming to the end of my presentation. Please allow me to summarize the key feature of each product. Ancamine 2769 and Ancamine 2712M provide properties and performance comparable to typical high salt hardeners based on cycloaliphatic amines. And 2712M has been formulated to provide coating system for fast cure with improved blush and carbamation resistant at low temperatures, where Ancamine 2739 has been designed to allow for a longer pot life and overcoatability with improved UV stability. Looking at Ancamine 2769, which is very low viscosity polyamide with high flexibility, we can get high corrosion resistant and excellent adhesion on poorly prepared surfaces. So before I come to the end of my presentation, I would like to say thank you to all my colleagues who supported this work, especially to my co-authors, Dr. Mike Cook and Dr. Steve Monaghan. And sure, I would like to thank you, all of you, for your interest and attention. So I think we can open the question session.
Thank you very much, Suhal, for your very nice presentation. I would suggest that we go straight into the question and answer session, as you said. Yeah. Shall we? Okay, I'll read the questions to you. And the first question already, can you explain the regulatory status of the ULE technologies?
Oh, all three products discussed today have a broad registration coverage. Detailed information on this you can find on corresponding MSDSs. There's a big list of inventories showing in which country that products are registered. Mm-hmm. So if you like, we can also share here MSDSs with you.
Okay, thank you very much. The next question, could you please define the application boundaries? Can they be used for low temperature applications?
Yeah, we have already reviewed data for ambient and 10-degree cure for those curing agents. But maybe I can also mention here that based on that platform, we are developing other curing agents for winter cure where the temperatures can drop down to 0 degree. So maybe that will be also next presentation here at that platform.
Why not? That sounds good to us. Okay, the third question. How did you measure the carbamation resistance?
So the carbamation resistance which we used here is an internal test method where we measure the water early water sensitivity of the curing agents. And the 5 is here the highest rating. But actually, if you like to know more about the methodologies which we use to characterize all our curing agents, which you show at my slides, those data you can find on our technical data sheets. And same is also for the formulation, anti-corrosive formulation, and the formulation which submitted for emission tests with AgBB protocol. Also, that data you can find on our technical data sheets.
Okay.
So we can also share it with you.
Yeah, that's a good idea. So people could have a look at the data sheets and learn more. Perfect. Thank you very much. Already the next question. We've received quite a number. Could you please repeat which are the typical epoxy resins to use with these 3 hardeners?
So our recommended epoxy resin here will be the liquid epoxy resin to achieve the low viscosity here. The main target here to have general lower viscosity and lower VOC levels. In this case, the liquid epoxy resin would be the choice.
Okay. Thank you very much. Let's have a look at the next question. What is the induction time? Why do some systems need an induction period?
So, like I mentioned before, most of the polyamides are incompatible with liquid epoxy resin or epoxy resin, but especially with liquid epoxy resin. When you mix it, you will see a heavy solution. But if you wait for a second where the reaction can start and amines can be more compatible with epoxy, the solution gets more and more clear with time. So to enhance the compatibility with liquid epoxy resin, you have to wait with that polyamide curing agent for a certain time to apply it, and after the apply, you can have the good wetting. Otherwise, you will have inconsistent film building. And the induction time in this case, after the mixing, you have to wait to apply that system.
Okay, thank you very much. Next question. I hope I can read it correctly. How can we obtain guide formulation of anti-corrosive primer? Have you ever evaluated undercoating rusting?
Can you repeat it again? If
Yes,
that's the question. Yeah.
I think it has 2 parts, this question. We can start with the first part. How can we obtain a guide formulation of anti-corrosive primer?
So again, on our TDSs, which we can supply, you can find the model of guiding formulation here.
Okay.
And the second question?
The second question was, have you ever evaluated undercoating rusting?
Undercoating. So what we did for 2769, we applied it on rusted metal and measure the addition. And to this, I have already showed the data. But I think there is more behind that question. So to get a better understanding, maybe we can take it offline. So you can reach out to me after the webinar and we can clarify it.
Yeah, I think that's a good idea, because you mentioned your email address already, and I will also read it again. So you can, of course, directly address our speaker for more questions. Yeah. Okay. Do you recommend it for use in floor coatings?
Again, here, can you repeat it?
Yes, of course. Do you recommend it for use in floor coatings? I think
flooring. Yeah,
the new
flooring.
systems are meant. Floor. Yes.
So those curing agents can be also used for any application where is low VOC level is targeted. and sure, flooring will be one of the application. It was not the focus of today's presentation, but again here, our flooring colleagues here, our colleagues which work in flooring application would be happy to assist you. But yes, it's the option to use it for flooring application.
Okay, perfect. Thank you. Our next question, is there a way to accelerate the cure at ambient temperatures for the 2769?
There are ways how we can accelerate it. Yes, it is possible, but if we have to keep in mind, if we accelerate the curing, that the pot life will suffer, so it will be shorter. Mm-hmm. But yes, it is possible to accelerate it at a certain level.
Okay, so it's possible. Very well, thank you. Have you measured adhesion also on galvanized steel?
For which product? Because we have introduced 3 products.
I know it isn't said exactly. I'm afraid. Maybe you can just choose one of the developments.
One data which I showed very briefly during the presentation was the pull-off test for 2739 in anti-corrosive primer. So where we got a very good addition here. So the results here was around 5 megapascal. But I think also here there is more behind that question, and it's more asked what kind of addition we can achieve with that curing agent. In all cases, we do observe very good addition to any different metallic substrates. Mm-hmm. But please contact me here again and we can discuss it offline.
Yeah, I think that's a good suggestion. Thank you. Do you have any chemical resistance data for Ancamine 2739?
So we do have some data on it. But again, here with chemical resistance, we have to define which chemicals are being asked. So therefore, again, here, I think we should take that question offline. Mm-hmm. We do have data for difficult chemicals, chemical resistant tests. So even here, we can share some data with you.
Yeah, very good. Thank you very much. Now, a very practical question. Can I make a mix of these 3 types in one formulation to get the most properties?
They are compatible with each other, definitely. But again, we have to think about what the target will be there. So again, if we try to extend the pot life, so that will be reflected in cure time. Mm-hmm. So they're always in conflict. If you have a very fast curing, then you will have short pot life. Mm-hmm. So then we have to think about which property will be targeted here. But yes, they will be compatible with each other. You can mix it. But again, we have to think about what's our target. Yeah.
Right. Okay, thank you. How can you reach improved UV durability?
So how we can reach UV durability? That's the question.
How can you reach improved UV durability?
Yeah. So we have to think about, again, UV durability, stability for epoxy system. As you all know, epoxy coatings wouldn't give very high-end UV stability, but you can see differences between epoxy coating systems to epoxy coating systems. Aliphatic curing agent, in this case, would give the better UV stability. And with 2739, we do see a better UV stability compared to other amine curing agents. So therefore, you will see after the applying, and also in white color, you will get light color here, which won't change too much during the time. So the yellowing tendency will be lower in compared to other epoxy type amine curing, other type amine curing agents.
Thank you very much. There's a question now about solvent resistance properties. What about the solvent resistance?
So I think that is again related to previous question to chemical resistance. Again, here we have some data for 2739, and we have to discuss which solvents, and please allow me to take that question also offline. You can reach out to me and we can discuss it. What is the target here?
That's a good idea.
Yeah.
I think we can allow for one more question. That's the one. Can we use these hardeners for epoxy surface tolerant coatings?
So we did show that 2769 can be also applied on surfaces which are poorly prepared and which give us also good adhesion. So I will say yes, but also in this case, we have to discuss more further what's the main target here. But generally, the answer is yes.
Perfect. Thank you very much. Well, I think it's time now to slowly come to an end of this webcast. But as you said, if there are further questions of the audience, they can directly address them to your email address, which is zuhal.hunchai@evonik.com. Yes. Thank you, Zuhal, for presenting your valuable information on a very complex matter today. And thank you, ladies and gentlemen, for attending today's webcast. A recording of this webinar will be available shortly, and further information on Evonik can be found on their website at evonik.com. Have a nice day and take care.
Have a nice day. Bye.
Bye-bye.